Hello everyone. Today we will be presenting about how to predict next day direction using artificial intelligence, which is written in our paper and is authored by my friend Rianwira Adirza, me, Maranusam Gende, and also Mr. Fairuz Iqbal Maulana. So why does our research matter? Our research matter because we aim to fix some problem, which is that the market change every second. Stock price are noisy and unpredictable, and traditional indicators react too late, and that makes traditional indicators not able to react in time. And so we created our model to counteract those problems or to fix those problems. And our model are aimed to be able to learn from their mistakes, which is learn from trial and error, and then understand market sentiment and also to understand financial news and sentiment. Our model can be used to help make smart investing decisions. We continue to what we built. So what did we build to counteract the problem above and to add to help make smart investing decisions? So we built a hybrid ensemble model. We engineered an advanced system that combines seven machine learning models like XGBoost and Random Forest with a proximal policy optimization (PPO) reinforcement learning agent. We use multi-source data type that analyze a range of data, including financial news sentiment via Finbird, market volatility through FIX, and currency trends from the dollar index or DXY. We also created custom-made trend indicators. We moved beyond traditional tools to create quote-unquote swing indicators that identify short, intermediate, and long-term market trends without typical delay of lagging indicators. We also created an intelligent voting mechanism. So we implement a majority voting technique that aggregates prediction from our models, allowing the collective intelligence of the ensemble to surpass the accuracy of any individual algorithm. So we continue to what data we use to train our model. So the data we use to train our model is consisted of two types, which is price data and sentiment data. For price data, we use E-mini Nasdaq 100 futures, the dollar index, and volatility index. For the sentiment data, which usually is used, is we use Bazinga Pro News.
Okay, and so how does our model works? First off, using the price data we collected, for example, the dollar and the VIX, we collected from the CME Group Broker and the Alpaca Benzinga News Pro using the Alpaca API for news data. For our price data, we convert those into custom swing trends. As you can see from the diagram, we started off from the far left, created a short-term swing low, which could be seen as a W in the market. And then if it breaks it, becomes an intermediate term low, which is shown in the with the red dot. And then if it breaks the intermediate term low and created a new stronger low, that's called the long-term low, basically. And with that long-term low, we can determine that specific market to just follow that sentiment, either a long-term bullish or long-term sell market. And then for our news data, we converted those into sentiment scores using Finbird, which is a financial Berta transformer model, which breaks down news articles into scores such as, example here, Nasdaq breaking all-time high. The Finbird use the their own functions and API to give us the scoring. For example, this one is one positive, good, bullish, market is going higher. And then for our Next article, we see stock market crashing. Okay, it's bad. It's negative 70%. We combine those data into one data set and then merge those together and then pre-process it. The pre-processing includes removing bank holidays, weekends, or any days where the market's not active, and also excluding those weeks where the news data can't merge with the price data because our news data is very much limited in data. We only have like 2,000 rows of news data, while in our price data, it's probably like 2 times, maybe 4K. And as you can see from all that pre-processed data, we put it in our 7 machine learning models. These 7 machine learning models are the logistic regression, decision tree, support vector machine, random forest, etc. There's still 3 more. From all of that, we combine those with majority vote, which is a technique that combines all the individual prediction into one. That result is sent into the reinforcement learning model, which in this environment, it takes in the observation data, which is the pre-processed data, sends it to the reinforcement learning agent, which is the proximal policy optimization model. And that agent will output an action, usually buy or sell. So it's either 1 or 0 into the environment that we already created. This environment sets up the reward system so that the agent can self-check and measure their performance based on whether or not their action is negative or something positive by our reward system that's scaled by a weighting system. Because as you can know, the market often moves higher than it does lower. That causes data imbalances that we need to incorporate into our reward system. And only by then, the agent can learn through our environment and give out this reward and state, which then completes the cycle until the RL agent learns that specific phenomenon. This thing is then compiled with the ensemble machine learning into our very own ensemble machine learning and reinforcement learning model. This final model will predict either 1 as up move or 0 as down move as shown here, basically predicting the next day. So what we learned is that the biggest thing we learned, our model basically predicts that by building a squad of AI prediction that talk to each other and a student, so to say, AI managed to learn from its wins by working as a team. Through this, we hit an impressive 69.97% in accuracy, predicting the next day market moves. We also founded the custom-made swing indicator shown on the previous diagram, which act like high-tech maps showing the road ahead, which works much better than lagging indicators like RSI. We learned that when AI reads the daily news to understand the world's mood, it makes much better decision than just looking at numbers alone. So in the end, we discovered that teamwork between AI models with the help of sentiments data are the ultimate secrets to stay out of the game. So that's all for our research paper. And for any sources, you can scan on the QR code and have a good day, scholars.